Hello ladies and gentlemen, my name is Decryption and I hope you are well. Doors. That's right ladies and gentlemen, we are looking at doors, but we're going to be doing special doors today. Now I've done a few tutorials on mine where we can open drawers, we can open jail cells, open doors. I'll run through that in a moment just if you haven't got that. But basically we have a door that we can open and close, right? So you can see as I walk up to the door it says door open, press E, the door opens, I can go in. I can look at the door, it'll say close as the guard watches me, close, boom, door closed. Dead easy, right? But the part what we're going to do today is all of this stuff in here is loaded 100% of the time. If you're far away, then World Partition, in my game at least, will hide it away. But it's still in memory. Like, I'm all the way over here. I'm even in this house. Here, look. I'm in this house and I'm looking in these drawers. So in this case, why is this house still got an interior with everything inside of it? If this has got loads of interactables, if those drawers are interactable, if you can sleep in the bed, write a piece of paper, whatever, it's all loaded. And that's going to take up a lot of memory. And the bigger they get. For example, if I go to this castle, which is not loaded, well, basically, let's stop the game. I have a castle over here if I enable it. If I'm walking around the castle grounds here, all of these houses have interiors, and all of them, if I slow down, are loaded. As you can see, if I go over to this one, okay, that one's not got one. If I go over to this one, it's all loaded. And the castle is the biggest one, so if I go inside here, as you can see, it's all loaded. But we don't need it to be loaded because we're not even in the castle. And it's surrounded by doors and stuff. So what we're going to look at today is an old PS2 style technique. I call it the PS2 style technique. It's still used in modern games now. But prime examples is an interior is not there until you tell it to be. Now, in some olden games, it changes levels. So if you imagine Skyrim, in Skyrim, as you enter a dungeon or enter a house, unless it's just an open house you can go in and out of, you will physically change levels. And the same is with Grand Theft Auto San Andreas. So you can see San Andreas has all the interiors on one map, and you simply load into a different portion of the map. I'm not talking about that. What I'm talking about is we can dynamically tell all this stuff to not render unless this door tells it to render. Now, if you've got big glass doors, you're going to have to find another way, whether you block out the windscreen or you do that cool effect where it shows the interior from an image, like Spider-Man. So you can see in Spider-Man, you have the cube effect. That room does not actually look like that. Of course, we could make it look like that, but the room's not there. Whereas in our case, we can make it so all of this interior here, that doesn't need to be visible. There is a glitch. I need to split mine up because that also hides, but ignoring that, the interior does not need to be visible. And that cup as well. Get that darn cup. There we go. So you can see, you cannot tell that's not loaded. Until we tell the door, now tell it to load, and we go in, and then everything is suddenly loaded. And then when we close the door, or we leave, then we can tell it to deload itself. And that means all the memory is still intact, and we have a good performing game. If you imagine this bed here, it's a lovely bed, isn't it? This gold, that's a gig in RAM. It's not. But if it was, you keep that rendered, it's going to be a gig. Trying to keep that there, whether it's RAM or GPU memory. We don't want that. So what we're going to do is tell it to unload itself. Now, it will take a bit of time for you to conquer your entire world. As you can see, I've got like 4 civilizations in mine. One's hidden away. It's gonna take a while to do. It will. It's games design. But if we put the code in there, then we can make it work. So, where do we start? Let's take a look at my basic door here. So I have a blueprint door here. I've covered doors loads of times, but I'll show it you anyway. I've got an interface, which is assigned to it, called BPI door. That has 5 functions. Open door, close door, is door locked, and it has an output of is locked. Locked state has an input, and is open has an output. On the BPA door, it's an abstract class there. All I do is set the lock state. I set whether the door's locked. The is door locked, I return it there. The set lock state, set open, they're just returning the variables. The main part of this is the open and close door. So the first thing it does is call this door state change, passing in the sounds. That's simply just a little quick thing down here where it caches the rotation, it plays the sound, and then it deactivates the interactable so you don't see close open as it's opening. And then play sound literally just loads it and then plays the sound. That's it. It plays the timeline, which selects whether it should open or close, and then does everything it needs rotation wise. And then on the finished, it simply calls door is open, reverses the variable, sets the text of the interactable, and then simply tells the interactable to open again. That's it. It's super simple door. But what we're going to do is take advantage of data layers, which is a Unreal 5 world partition thing, where we can tell specific interiors to load or unload. And it's going to be really useful to make our game performance. So like this house here, it's 3 stories. We can turn all of that off if the doors are closed, which is going to be really cool. You can only use this if you are in Unreal 5, and you can only use it if you're using world partition. If you're not, then I don't believe you can use data layers. I think there is a one called layers or levels. I've never used them. The other option you can do is you can do it the old school way where you change levels. So you fade to black, change a level. So for me, most of my houses are just going to be load the interior as you go to them. However, if I enable the castle over here, I'm going to make it so nothing inside this castle is loaded until you interact with this door. And at that point, I'm going to level change Skyrim style. So then I can load everything in the castle. And because we're changing levels, we can make the castle more detailed. So we can have more NPCs walking around. If you imagine this entire castle is loaded with the entire world, all these NPCs around here will be walking around. They won't over there because we'll do optimization technique. But all the NPCs here will also be in memory, even though we're like, 5 stories up in the castle. Whereas if we level change to the interior of the castle, suddenly we don't need any of the outside rendered. So it's a double benefit, but it's going to be really cool. By the way, epic mustache. But yeah, so let's start with the data layer version. If you are using Unreal 5 with world partition, you can use both, and I am going to be using both. But just use whatever you can. So let's start from the beginning. What is a data layer? So a data layer is a type of layer, if you've ever used Photoshop, or a group of actors that you can toggle on or off. So to get the data layers window, you simply go to Window, World Partition, Data Layers Outliner, and you can see we have a list of existing ones I've already created. You won't have any. But it's pretty simple. It's just like your outliner. You have a visibility flag, where you can make it visible or not. Then I can see I've got my entire Elven pack. I can unhide it. And then you've got whether it's loaded in memory. So just because it's not visible doesn't mean it's not loaded in memory. It's loaded in memory, ready for you to go bang, make it visible. That's why it's so quick to make it visible. If I unload it from memory, you'll see it took a lot longer to do. Not massively amount of time, but it's still enough that your users are going to see it. So you don't want that game freeze. So what you'll typically do is you will load it in a cutscene if you've got one, and then when you want it, then you'll make it visible, and it's super quick, just like that. So checking this on and off, I can actually see my GPU's memory going up by 2%. So just to show all of this here. And then if I make it invisible, it doesn't really change it that much. So yeah, it does do it. So what we're going to do is let's create a new data layer. And there's 2 types of data layers in Unreal. There's an editor only one, and then there are asset based ones. So the editor only ones is literally in the editor to make lives easier for developers. That's it. If I don't want to see that entire Elven as a developer, I can just uncheck it. But the other option is asset based data layers, which is this one here. So you can see you've got create new private data layer, which if you hover over it is editor only, and then you've got data layer here, which is with an asset. So let's go and create a new data layer, and then I'll just create a folder called data layers, but I've already got one. And inside here, let's name it. I'm going to do this first building here. So I believe it's DL_Elven building inside 4, because it's the 4th house, I believe. And we'll start that. So you can see it's added it here. Whatever you name the data layer is what it'll be called in here. I don't mind it being called DL Elven building blah blah blah. If I stick to that standard, the alphabeticalness will organize itself. So what I'm going to now do is come across to all of my actors that I want to be considered the building inside. So I'll select the glass, holding shift, I'll click on other things, and I'll click the floor as well, because let's face it, you don't need the floor. And there we go, everything's been removed that we don't need. Yeah, pressing H to make sure I've got everything, and then Control Z to undo it. And then I'm going to right click on the data layer and choose add selected actors to selected data layer. And you've equally got remove if you accidentally put one in. So I'll click add. If I toggle the visibility now, you will see the interior disappears, which is perfect. If I uncheck it, obviously it's not loaded in memory, so I can no longer make it visible. So if I show it again, I can make it visible. You can double click it if you want to work in it, which I believe is anything you do will automatically be added to the data layer. If that's something that'll be helpful for you. I don't use it that often, but I'm still getting to grips with data layers. Now, there is one caveat that we need to cover off now, and it's something that got me the first time I was using it. If you click on your asset that you are going to show and hide, and in the details, so search for is spatially loaded, you need to make sure that this is ticked, but you also need to make sure it's not controlled by a parent. So what that means is if I come to my outliner, you can see I've put this inside at root. It's basically doing nothing. It doesn't exist in a parent somewhere. However, if I go and find the parent for this house, so I'll just click the house here. If if I put this back inside that parent there, this parent is controlled by another data layer, what controls this section of the map, and that's okay. But this interior here is now locked to that parent, meaning it will follow whatever the parent's going to do. I don't know why Unreal doesn't really specify this anywhere. I'm guessing the way data layers work is if the parent's loaded, all the children are recursively loaded as well, meaning the interior that we're wanting to control comes somewhere else. Super simple fix, just don't parent it, stick it in a folder. So I'm going to stick it inside this buildings folder here, like so. And now you'll see if I turn that off, it's there. If I select everything else that I want to also be, I'll just drag it inside there because it's all the same anyway. If I hide this now, and the final one is this one, there we go. Yeah, so now all that can be invisible, and the spatially loaded, if I click the parent, which is one we're loading, is spatially loaded. We've got control over it. It's just an important thing because the code we're about to do will fail and it will just always load it because this bit is always loaded. So now we've allocated our assets to our data layer, some other things we need to just quickly check on is in the details, it has its own mini details. I don't know why it's not part of the details. It's like it gets its own sub details panel. Bit weird, but it's alright. Inside here, the flags that we want to look at is the initially visible and loaded. These are only in the editor. So when you first come into the map as a developer, do you want it initially loaded? Well, I don't want it initially visible or loaded. So when I reload my map, that won't be loaded anymore. So if I just come and find my map, and if I come back into it, even though that's set visible for me, you'll see it's invisible as soon as I've come back into the map, because we've set the editor default. It's going to be a good practice to hide some. So I'm going to just enable it again here, because these are only temporary, these ones, just for the editor. And then the other one we need to look at is this part here, initial runtime state. So when the game first loads, this is the runtime, what do we want it to be done? We've got three options. Unloaded, it's not in memory, it's not visible. And that's what we want by default, so we'll click that. But the other options are loaded, which means it's in memory, but it's not visible, so you can't see it. And then you've got activated, which I don't know why they've called it activated. Surely visible would have made a bit more sense. I don't know, but activated it is. Activated means it's in memory and you can physically see it. It's rendering. Whether you're looking at it or not, you know, that kind of thing. So we'll stick with loaded like so. And that's really the only options we need. So let's actually customize our door now to tell it to hide and load that. So if you've got a door, that's going to be the best point to start with. But you can equally do this with a key press, a keyframe, anywhere you want to put it. I'm just hiding it behind the door. So what I want to happen is as soon as I tell this door I want to interact with it, I want it to do its normal interaction stuff, but then I want it to wait. So I want it to deactivate the interactable so we can't keep clicking on it. And I want it to lock itself down, however. And then I want it to load the assets in the background. And then only when it's finished loading the assets in the background, then the door can open. A prime example of this is Batman Arkham Asylum, the first game. So in here, you can see every time you click on a door, it does that loading sequence where the door opens and stuff like that. Sometimes it's very quick, it just looks like a door. However, sometimes you'll notice it takes a while to open. So as you can see now, they've clicked on the door and it's just taking ages. What it's doing is unloading stuff behind you and loading stuff in front of you. Probably far away through another door or something, but it is loading it. And if your computer's super fast, you'll probably never run into this. If you've got a slower computer, you'll see how it's a bit slow. And that's because it's loading it all in memory. And that's the kind of effect I want to go with. I want you to click this door. If you're on a really slow PC, you'll just have to wait for a minute. Maybe we'll play a knocking sound. Maybe, I don't know, play a rustling door sound, anything you want. But then, most of the time, it's going to load a small amount. It will instantly populate this and the door will open. So it's super, super simple to do. So where we've got our open door here, I'm actually going to come and make a bit of space, like so. And then, after the door state change, I'm going to right click and choose Get Data Layer Manager. And now in, I believe, Unreal 5.3, 4 and 5, you have to use the Get Data Layer Manager. It's the newer one to use. If you're in Unreal 5.0, 5.1, 5.2, you will use the Get Data Layer subsystem. I don't know why they're moving away from the subsystem to the manager, and then in other places adding the subsystem instead. I don't know, but that's what you need to use. You can technically use the subsystem in the newer versions, but it's deprecated, meaning they're eventually going to remove it. So we'll just use the data layer manager. In both ways, it should be the same. Set data layer runtime state, like so. And what it'll do is it'll ask you for a data layer asset that you want to load, and we want to load my Elven building inside 4. The in state, so what do I want to change it to? Well, I want to change it to activated at this point. And then what we could do is we could just plug it straight into play and carry on. However, this goes off and does something in the background. It's not set as a latent node for some reason, but it does finish later because it sends it off. You can try it. If you load something big, it will just go straight past it and let you in. It's kind of like it's like a function that calls an async method. So what we need to do is we need to tell it to wait until it's loaded. And this is super easy to do. So we're off of our data layer manager. We're going to drag off and do get data layer instance from asset. And that's because we're using the asset. And in here, we're going to choose our DL Elven building inside 4. So this is super easy to do. So we're going to drag off the data layer manager, and we're simply going to type assign on data layer instance runtime state changed. It's a mouthful, I know, but that's what we're going to use. And this event dispatcher is basically going to tell us every time a data layer state changes. Now, since we're stood in front of the door and we're telling it to activate, that's going to be a data layer change here. So what I'm going to do is off of this data layer here, I'm going to do equals equals. And what data layer do we want? Well, in this specific case, we want our data layer here, which what I'm going to do is actually promote this to a variable, data layer to load. And then I'm going to copy this down here. So we're actually checking that the correct data layer is loading. So say if you're jumping or teleporting around, other data layers are going to be loading. We don't care about that at that time. We want our specific door. So if it's loaded, and then what I'm going to do is also say and then check the state. So I'll do equals equals and do equal enum and plug it into here. We will tidy the code up in a moment. And I'm going to set this to activated. The reason we're checking the state as well is technically the first thing a data layer does is load itself into memory, which may, I don't know in the Unreal code, trigger this state change because it's gone from unloaded to loaded, but it's not visible. We need it to be visible. What the Unreal code's then going to do is then make it visible, which may fire off a second state change, which we're checking for. So we're checking that our specific data layer is loaded and the enum has also loaded, which is perfect. And then what we'll do is add our branch and then connect true to the play like so. So it's a bit of a long-winded thing, so let's tidy our code up a bit. So I'll just drag most of this out a little bit, make some more space. I'll put the download for the door in the description with everything you need for it, so it's a lot easier for people to do. So we open the door, we tell the data layer to load, and we come into here. It checks if our data layer has loaded and done everything it needs, and then it plays like so. And that's only when we're opening a door. If we're closing a door, that's something we're going to have to figure out in a moment, because we need to make sure that if the player's inside and they close the door, that it doesn't unload everything and they just fall to oblivion. We need to make sure that they are outside the door and they close it. So, in theory, we should be able to give it a test now, and it should load our data layers up. So I'm going to compile, save, and I'll come back to our game and I'll run it. The first thing I'll do is check that our data layer is in fact currently unloaded. We don't want it to be loaded. So I'll press F8 and you can see if I come up, you can see there's no interior. Perfect. And I'm going to escape out because I've completely forgot to assign the data layer to it. So I will come to my Elven Door 4, which is my child blueprint, and on the data layer you can see I've pre-assigned it there. That's fine. Just make sure you assign yours, otherwise it's not going to load. And we'll do that again, and you'll see if I press F8 and have a look, the layer is successfully unloaded. If I go back in, now if we run up here, if I angle my camera, you should be able to see. If I press open, the door isn't going to immediately open. It'll first load the interior, then the door should open. Interesting. So, it didn't do anything, which is fine. It's loaded the interior, so our codes work successfully. Now, what I'm immediately thinking is it could be a couple of things. If this data layer runtime state runs immediately, it may not actually assign itself to the state change before it happens. That's my first feeling. So what I'm going to do is drag this set data layer runtime state over here and just reorder them. So the first thing it does is bind to the event, then the second thing it does is actually tell it to load, like so. So that's the first thing we're going to try, and let's see if that fixes it. If not, we'll keep debugging it, because debugging is a good process to learn. And I'm going to start keeping some of the mistakes in the videos, because then it shows you everybody makes mistakes, really. So you can see we can't see an interior. If I press open, okay, so it's still not opening the door, so something's not allocated correctly. So if I come back to the door here, what I'm going to do is I'm going to press F9 on the Get Data Layer Manager to add a breakpoint, and I'm also going to press F9 on our branch here, so after the event. So we should see it from here go to there, to there, to there. Then it should hit this because it's called the state change. Also, pause the video if you have already seen what's wrong and comment below. See if you've figured it out before I do in real time. So you can see if I press E, it's gone to the data layer manager, which is correct. I'll press F10 to go across, it's hit the event. Press F10 again, it's gone to the run set data layer runtime state. I'll press F10 to go past, and now we have hit this. Interesting. I can now hover over and almost probe the variables. So is the data layer what's loading the same as our data layer to load? So you can see if I hover over it, it says false. Interesting. So the data layer that's currently loading is not the same as the one we're passing into it for some reason. The state of it, however, is true, so it is activating it. So I'm going to press escape to break out of it and press F9 on these to remove the breakpoint. So for some reason, the instance we're loading here is completely different to the instance we've got here. So what I'm going to try instead is I'm going to get the data layer manager again down here, and I'm going to do get data layer instances. Instance from asset, like so, and then I'm going to click on that one and I'm going to check if it equals this one instead. So what I have a feeling is this data layer asset, it's a standard blueprint in some terminology. That blueprint doesn't exist in the world. It's like a class. What we need to do is when it's loading it like that, it's creating an instance of it. And then that instance is technically a different actor at that point. So let's see if I am right. So I'm going to connect this up like this. I'll just poorly organise it for now, because then we can at least check. And if we're right, then we can do it. So to test if I'm right, I'm just going to run it really. So I'll come down here again, right click, play from here. And this time it would open the door hopefully correctly. So if we right click and do play from here this time, when we click on the door, it should load the interior and then open the doors. So press E, boom. Everything is loaded in memory. How cool is that, ladies and gentlemen? So you can see it's now in memory. And of course we want to be able to close the door and have it deload from memory as well, which is something we will look at. So, the next part is then, how do we tell which side of the door the player's on? Because if we close it here, and we unload this, the player's going to fall down. We don't want to do that. Likewise, if we open it again, it already exists, so it won't open the door again because the state hasn't changed. It could very well be that you keep the door open and wander away, but then we'll let world partition take care of that, because it'll just hide it. Equally, you could do the distance thing there. So how do we best tell what direction the player's on? Because if we had a box collision here, on the outside, so when they come through it, if the player's sneaky, they can just trigger it from here and they'll never trigger the box collider. What we're going to use is a mathematical function called the dot product. You may have heard of this before. If you have, great, it's fantastic. I can't directly explain to you what it does, I'll be honest. So I asked ChatGPT to explain it like I'm a 5-year-old. It was quite condescending a little bit, but I don't think it meant to be. But what it's basically saying, I've put the page on the screen now, is the dot product is a tool that helps you compare if two things are pointing at each other and what direction. So if we compare the dot product of the door to the dot product of wherever the player is, or we compare the two locations via a dot product, then it will tell us whether we're on the forward direction of it, and that goes all the way around to here, in which case we can't close the door past here anyway. But if it goes past this point, past here, you know, the halfway point, then it turns to negative numbers. So if we close it here, it will be a negative number. If we close it here, it will be a positive number. And it's using the right axis of this door here. So basically, this point here will be almost 0 and then starts going into negatives. It sounds complex, but it's actually only a couple of nodes, and it's really easy to do. So let's have a look at doing it, and then you'll be able to see what I mean. So in the BPA door, just as a test, what I'm going to do down here is I'm going to add a tick function. And this is not permanent, we're just doing the tick function so we can see it in action and we can learn together. What I'm going to do is I'm going to get the self, which is the current door, so get reference to self. And then I'm going to get its right vector. Now, a lot of things online say you're supposed to use the forward vector, but our door's sideways, look, because that's where most doors are going to be when they're placed sideways. If you rotate your door like that, it'll probably be a bit different, but so we're going to have to use the right vector, which is okay. And then from this, we're just going to apply a dot product like so. Now, it needs a secondary vector, and we can get this by getting the player's position. So if we do get player pawn and then get their location, get actor location, we can then minus this away from the self's actor location. So if you've ever done a distance check before in Unreal, you pretty much have the same thing here. The only difference is we run the dot product and it will tell us whether or not that vector and our player's vector are on either side of it. So if we grab this now and just print this out like so, I'll just add a key of door just so we can see it. But what you should see now is it should continuously print the dot product between our player and this specific door, so we can see the numbers change. So you can see at the top around the AI, we're currently 565. As we get close to the door, it goes down, but we can never hit 0. If we go around here, you can see it's still positive. If we go around here, it's still positive. But as soon as we break that 180 rule here, it starts to go negative. And you can see all the way around here, it is negative until we come back up to the vector and it goes positive again. So if we open the door here, you can see it's always going to be positive. If we close it this side, you can see it's already negative, look, because we're on the back side of the door. We're not counting the mesh, this part here, the blueprint. When we close it, you can see, well, we're negative. We know we're on the inside. If I open it, it's going to glitch because we've already loaded it. But if I restart it and do it from here again, if I close it from the inside, you will see it will close it with a positive number, meaning we're on the outside. So if I close it now, you can see we've closed it with a positive number. So that's how we can check whether we're on the inside or the outside. Now, one thing I haven't checked that I am just going to go and check is I'm going to put this door here and I'm going to rotate the door a different direction. In theory, it should still work because I'm pretty sure I tested it a minute ago, but I just want to test it just while we're here, just to make sure. So, we've got 2 numbers actually, haven't we? Temporarily, I'll just delete this door here. There we go. So you can see now, I'm positive, 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 go behind the door, negative. Okay, good. So it means the door's going to work in any angle we want to open or close it. Funny thing is, if we open this now as well, you can see there's no interior. If we open this, haha, it loads the interior. So make sure you've got your variables assigned correctly there. So right, let's put that back then, and let's crack on doing our dot product check. So we already have the code here to check whether we need to unload. So I'm going to delete this event, and I'm going to add a custom one called check unload data layer. And I'll just plug this in over to here. Then, instead of printing this out, what I'm going to do is check if the dot product is more than 0, and then add a branch in. If it is more than 0, then we can successfully unload the interior because we've already checked it. Tidy this up a bit, because we've already checked we're on the outside. So, I'm going to come and copy the get data layer manager and the set data layer runtime state here, and I'll paste it down here. So, on true, because we're positive, we get the data layer manager, and then we're immediately going to set the data layer runtime state to unloaded, like so. And then all we have to do now is call this function in the correct place, this event. So after our timeline finishes, where it's opening and closing the door, right at the end of all of this, when we reset the interactable, I'm going to add a branch, which is simply going to check, is the door open? If this is false, it means the door is currently closed. Then that's when we want to come here and we want to check unload data layer. Just on the false. We don't want to do it on the true. So let's go and try it now. So it should successfully unload it when we're on the outside, which means we should be able to respawn it when we open it. So you can see it's not there. It all spawns. If I close it here, it should unload everything. There we go. Everything is unloaded because we closed the door. How cool is that? If we reopen it, it goes back in again. But if we close it from this side, it shouldn't unload it because our dot product is negative. There we go, ladies and gentlemen. How cool is that? So, there is a couple more stuff we need to fix before we do move on. For example, the instance already exists, so we can't technically get back out, which is not a good thing. So, easy fix. On our BPA door up here, while we're getting the data layer manager and binding to the event, what we actually need to do is check whether it exists already or not. So, I'm going to get the data layer manager, and I'm just going to break this off for a moment and move it across. And then down here, where we've got the get data layer instance from asset, I'm going to tidy this bit of code up because it's a bit messier than I'm happy with. There we go. So I'm going to copy this bit here. I'm going to paste it up here. And what this is doing is getting us the spawned instance of that one. And then what we can do is we can say get data layer instance runtime state, because we're changing the runtime state. We need to plug in the data manager, such as that there. And then we've got the enum. So we can say equals, if it's currently set to unloaded, then we want to continue off and do that. This code's getting very long, so let's make some more space for it. Make a lot of space for it. We can always rejig it later. There we go. So if it's currently unloaded, which means it's not in memory, then we want to carry on, bind to the event and let it continue. However, if it's not unloaded, it means it's basically not visible. We can take the false straight into the play here, which I'm going to tidy this code up in a minute because it's getting rather messy and I'm not happy with that. But what this will now do is if it's already loaded, then it will just bypass that and then just open the door. If it's not loaded, then it will bind to it, tell it to load and go for it. There is one other thing I've just found that we need to fix. we're not actually ever unbinding from it. So I'm going to move all this data layer stuff across like so, and like I say, we'll tidy up in a moment. Once we successfully bind to it and we call this event, and before we call the true, so we'll put this back over here, if it's true, then that means we've successfully gone through all the phases, we're ready to open the door. At that point, we don't care about tracking the state anymore. So I'm going to get the data layer manager, and after the true, I'm just going to add it in and drag off an unbind event from data layer instance change there. And we can plug this event back into this event all the way over here. So what we're doing now is once we come in, we check the state, we check that it's our actual door. If it is our door, we unbind this code from it because we don't need to run it again, and then we open the door. Oh, plug the target in. Let's give it a bulk test, and if we're all good, then we can tidy the code up and we should be good. We now have doors that open and close. So let's see. So we run up to the door. You can see it's unloaded. If I open the door, everything loads up perfectly. If I close it, everything deloads. Fantastic. So we'll open it, we'll jump on in, and we'll close it. Everything remains. However, if we open the door now, can we get back out? We can. Look at that, ladies and gentlemen. We can span the door open and closed. It won't care. We can stand almost to the edge, but we can't get out. As soon as we stand out, the door deloads everything. How cool is that, ladies and gentlemen? Super optimized way of making games, which is really, really cool. So if that's all you need and you're happy with what we've done, thank you for watching, ladies and gentlemen. I hope you enjoyed. However, this portion of the video, I'm just going to tidy the code up because it's a bit messy and I don't like it, and we can definitely do better. So the first thing I'm going to do is from this event, I'm actually going to drag off and just do create event there. Now this is badly named. It's not adding a custom event, it's creating a call to an event. So we can choose a matching function, which is that one there, so the event. But it now means we can basically select all of this and move it because it doesn't have to be tied up there anymore. So we can move that over here. Unbind the event here. I believe we can call create event again from this one, and we can just tell it which event to remove from, which saves the big line back over there. What I'm also going to do is make some space down here, and we'll add a custom event called play door open. And we'll move the close code as well, but also the play one over here. We'll move all of this down here. Apologies if you can hear my dog snoring. She's happily snoring away. And we'll plug the play door open into the play, like so. So if we wrap this in a comment, open/close door timeline. So what this means now is over here, after our door state changes, we come over here, we can drag off of this and call play door open. So after we load the interior, but it also means on the false up here, we can just make some space here and then tell it here, you already exist, just simply go straight to play door open like so. So that is a lot neater. I've got a lot of variables dragged across, which I'm not a fan of. So what I'm going to do to clean this part up with these long lines, I'm going to take the data layer manager and I'm just going to bring it over here again, just so it's closer to it because it makes it a lot easier. So we can unbind that and connect it over to there like so. There we go. So it does mean it's getting the data layer manager twice. It's going to be very, very quick. You could cache it if you want, but then it means we've got a variable that for most of the doors is sometimes used. There we go. So we can now shrink this code up. So that code's been tidied up a lot. That looks a lot nicer. I don't know why that one's got a different color comment, but that's all good. So now this one, play door open, play the timeline, does everything it needs to rotate it, comes in, sets all the text, checks if it needs to unload the data layer, and then this one down here handles the door state change and the unloading of the data layer. Unload the data layer. There we go. Compile and save. Let's just check if our code refreshers worked. And now you can see we'll walk up, we'll start the door, and it will open, close the door, and you can see it unloads and loads perfectly. Now, this is a bad example on this one because I've accidentally put the external stuff in with the interior. But there's nothing stopping us adding it to any door in the realm, to be honest. So there we go, ladies and gentlemen. There is the basic door with a data layer aspect. Now, this video is getting quite long, so what I'm going to do is split off part 2. And in part 2, we'll look at adding the feature where it will sometimes pick the data layer, unless you've specifically stated not to, in which case we'll tell it to pick the map so we can fade out and load to a different map based on whether or not the variable is populated. And what we'll also look at adding next time is double doors. If you open either door, it should open the other relevant door and still perform the same code. And that's what we'll look at doing next time. So thank you for watching, ladies and gentlemen. I hope this helped. If you've got any suggestions for improvements that you'd like to see or extra tutorials, please let me know below. I'm going to be releasing some new animations soon, so make sure you subscribe for that because they're always cool to have. My name is Decryption. Thank you for watching, and I will see you next time.